Hello guys, welcome to our class. This is Normal Science Tutors Online. I remain Otobo Michael, bringing physics direct to your very doorstep. So please, for today we are going to be looking at resolution of a single vector into two components. Is that okay? So if you are not subscribed to this channel, please subscribe. Click on the subscribe button. Also click on the notification button. Click on the bell that is ringing so that when we upload any new video, YouTube will notify you. You can also reach us through the WhatsApp number that is showing on your screen. Right, so we are going to our class for today. Get your writing materials, get your calculators, and get settled. Right, so welcome to the class for today. So for today, we are looking at resolution of a single vector into two components. Resolution of a single vector into two components. Actually, a single vector can be resolved into two components, and those two component vector will represent that single vector in magnitude and direction, right? So a single vector inclined at an angle can be resolved into two components, the horizontal component and the vertical component. So if we have a force that is inclined at angle theta to the horizontal as shown below, I've just represented them in the drawing. So if this is a force V that is inclined at angle theta to the horizontal as shown in this drawing, the vertical component of this force is equals to V sine theta, while the horizontal component is given to be V cos theta. Then if this vector is inclined at angle theta to the vertical, assuming this vector is inclined at angle theta to the vertical, this vertical, if it is inclined at angle theta to the vertical, then the vertical component will be V cos theta, and then the horizontal component will be given to you to be V sine theta. So depending on the angle of inclination of the force, then you will know which of the equation to use to solve for the problem. Is that okay? So these are the formulas for solving for resolution of a single vector into two components. I also want you to take note of this, that if you have a body that is pulled along a horizontal surface by a force F that is inclined at an angle theta to the horizontal, the force that is pulling that body along the horizontal direction is given to you by F cos theta, while the force that tends to pull the body off the ground along the vertical direction is F sine theta. So that is also like the vertical component of the force, or the horizontal component of the force, and the vertical component of the force. Is that okay? So we are going to solve some problems to drive home this equation that we just discussed. Right, so let's go straight and solve some problems. Okay, so this is a sample question. A wheelbarrow inclined at 30 degrees to the horizontal is pushed with a force of 150 Newton. What is the vertical component of the applied force? What is the horizontal component of the applied force? In what direction will the wheelbarrow move and why? So you can represent that on a drawing. This is horizontal force, and this is vertical force. This is horizontal force Fs, and this is your force vertical. Okay, so your wheelbarrow is pulled along that direction at 30 degrees to the horizontal. This 30 degrees to the horizontal. 30 degrees to the horizontal. So you can actually complete that. You can complete this triangle. You can complete this triangle. So they said that the force that is pulling it is 150 degrees. This 150 degrees Newton. I mean 150 Newton. It's 150 Newton. So they said, what is the vertical component of the force? V component, vertical component of the force, which is Vy, is equals to V sine theta. So this gives us what? 150 times sine theta times sine 30 degrees, sine 30 degree. So if you work that out, you have 150 times sine 30 degrees 0.5. So the vertical component will be equals to what? 75 Newton. Quite easy, right? So that is quite easy. Same thing with the horizontal component. Vs equals to V cos theta. V cos theta. So that gives us 150 times cos 30 degrees is 0.866. So if you multiply that out, you're going to have 130 Newton. Okay, so since the horizontal component is greater than the vertical component, it means that this wheelbarrow will move in the direction of the horizontal direction. It will move in the horizontal direction. It will move in the direction of the 120 Newton force. Okay, so that is just it. That is just it. So forget about the mini grammar here. That is just it. So this kind of question, in less than how many minutes you are done with it. Is that okay? So I hope this is clear and this is well taken and well understood. Okay. So this is your own test page. Please try your hands on this problem, this resolution of forces. Try your hands on these problems. It's a plane flies with a velocity of 1000 km per hour in direction of 60° east. Find the effective velocity easterly and northerly directions. Okay, then two forces whose resultant is 100 Newton are at right angle to each other. If one of them makes an angle of this with the resultant, determine its magnitude. So these are just simple questions that you'll be able to do readily. Right, so try your hands on them. Snap your answers and post them on the WhatsApp number that's showing on your screen. I will look at them and make my own comments. So this year was ending our class on this particular topic. Thanks. If you have not subscribed, to this channel, please click on the subscribe button. Also click on the notification button so that when we upload a new video, YouTube will notify you. This is Nobleman Science to Source Online. We are bringing physics class direct to your very doorstep. Please give us a like, give us a positive comment so that we can continue to upload more videos. Reach us on this WhatsApp number that is showing on your screen. Thank you. We'll see you on our next class.